Welcome to Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle. I'm here with my co-host Gary LaRude. Today we are going to discuss the RF energy market, that it was a big deal a few years ago, but seemed to kind of fade out. Here to discuss that with us is Mark Murphy, MiniCircuits Global Market Manager for the RF and Microwave Energy Group. Welcome, Mark.
Hey, good afternoon.
So we first started hearing buzz about SSPA technology for microwave ovens maybe 4 or 5 years ago. And you also saw people bringing them to the shows and cooking things to show how they evenly cooked. So what's happened to the market since then? And what are some of the applications driving the demand as you see it today?
So the big thing is that the RF power transistors performance has continued to improve, and they've also become more cost effective. Device manufacturers, the semiconductor guys, they've done a really great job there. And as a result of those two things, we're seeing the solid state solutions starting to be adopted more often. So we're also seeing customers starting to understand the benefits of control in their applications, and they get this control from a solid state solution. Now the funny thing is if you look at solid state, it's actually been around a long time. It's been used in a lot of applications. For example, in semiconductor manufacturing, there's a lot of RF energy used to generate the plasmas that etch the delicate patterns that are needed to create the ICs that we use in our mobile phones and electronics. If you look at particle accelerators, these systems, they're running 24/7. They're pretty expensive. And we're seeing a lot of these guys moving from tubes to solid state, purely on a basis of reliability. So they need to have that system up and running, and they don't get that reliability with tubes. So that's another area that we see solid state beginning to find its way into the market. And then we're seeing customers looking at the total picture. So they're looking at the total cost of ownership, and they're coming to the conclusion that with a solid state system, that they get more reliability. So they get higher uptime, which means their maintenance costs are lower. And in some situations, they're getting more control and they get better product yields. Or in some situations, this control is enabling techniques that were just not possible and with tubes. A lot of the market we're seeing is happening really in the professional side of the industrial, scientific, and medical markets. For example, in the medical area, we've seen solid state being used in hyperthermia applications. So it's a form of cancer treatment where you direct RF energy essentially into a tumor, and you heat that tumor to 43 degrees. And after that, then the tumor is very sensitive to radiotherapy or chemotherapy. It's a very, very useful application. In the scientific world, where controlled doses of energy are needed, solid state is really starting to pick up. And you see examples where heat is being used to heat small patient samples to improve the speed and quality of different virus detections and disease detections. And obviously in today's world, a very, very useful application. Further, what we're seeing industrial heating applications really starting to use solid state where they have different materials. So materials that have a multitude of applications ranging from, say, disinfection, pasteurization, sterilization, drying of materials, heating and preheating materials for a further reaction, and many, many more. So the fact that solid state can adapt to the real-time changes in these materials, we're seeing it as a big game changer for the customers. And I mean, I've even seen an example where RF energy has been used in 3D printing, enabling materials that essentially couldn't be used beforehand. So since we have recently introduced our first product to the market, we've been surprised by the diversity of the different applications we've been seeing, and it makes it a very, very exciting place to be active right now.
Wow, you've really outlined a large number of very diverse applications for RF energy. And this is not an area that MiniCircuits has been involved in, at least to my knowledge, in the past. What were some of the factors behind your decision to go into this new area?
If you look at MiniCircuits, we've got more than 27 product lines covering most of the RF functions that you can essentially think of, and are, as we like to say internally, covering everything RF. So our customers love working with us. They find it easy to buy our products at a very reasonable price. And a few years ago, I think it was around October 2019, we set up a new high power amplifier design team. And at the same time, we realized, once we had that team in place, we realized along with our capabilities in supply chain management and also in manufacturing, that it really wouldn't be a big effort to provide turnkey portfolio for the RF and microwave market. So we did some market research, and essentially what we concluded was that the RF and microwave market was crying out for a professional supplier to step in and put these turnkey solutions into the market. So with the diversity of our offering, combined with the high power design capability, we're actually an ideal partner in the customer's perspective, and we've seen this clearly in some early engagements. And then if you also look at it more broadly, if you look at MiniCircuits, we've been supporting these different RF markets for more than 50 years. And that gives our customers peace of mind, knowing that we have all their interests covered. So there was essentially a great match for our capabilities and where the market was going.
So Mark, what products have you developed so far, and what do you think differentiates MiniCircuits' offering in the market?
Yeah, so we're introducing a number of solid-state power amplifiers for RF and microwave applications. So the first one is a connectorized power amplifier. It's the ZHL2425250X+. So that's a 50 ohm in, 50 ohm out amplifier capable of delivering up to 300 watts in the 2.4 to 2.5 ISM band. So what we really wanted with our amplifiers was to make them ready to use straight out of the box, in the sense that the customer, all he really needs to do is put on a power supply, and there's no need for power meters, power detectors, and all that stuff. All the data comes directly out of the amplifier. Now, the good news is we've managed to achieve this. And this is essentially, we think this is going to make our customers' lives a lot easier in terms of system time, design, application development, and time to market. So this specific 300 watt amplifier, it includes RF power detectors for the forward power. It also measures the RF power on the reflected power. We've added in a circulator to protect the amplifier from unwanted RF power on the output terminal. And in these applications, you will get a lot of that stuff. It's not a nice 50 ohm and 50 ohm out matched environment. You're going to get loads things on the output terminal that you just don't need. So that makes it robust. You can measure the temperature, you can measure the current. There's voltage sensors. We've got a control circuit on the amplifier, which has an analog to digital converter. It has a digital to analog converter. So essentially allowing all the detectors and all the sensors to be read out, both in a digital and an analog world domain. And this then is all easily fed back into the customer's controller system through an I2C connection, and response times are in the order of microseconds. So all this data from the amplifier is essentially available for the user to add their own secret application intelligence and control. So it's absolutely, I'm really excited about it. But hey, I have to apologize. I think I went a little bit deep into the technical details, but we're really excited about this platform. And we think we've created something that has all the functions the customer is going to need today, and probably all the functions that they're going to need later on. And oh yeah, I also forgot, we added a lot of safety features for the amplifier that we think will make it impossible to destroy. So if the customer connects it up wrong, or if something happens inside the amplifier in an environment that it shouldn't be in, it will tell the customer and it will shut itself down. It'll let them start it up again without it being broken. So it's just really nice. Yeah, so that was the amplifier. And then further to this amplifier, we're also introducing a companion product to this, which is an intelligent, easy to use controller signal generator. It's called the ISC242525+. So this is a product that closes the feedback loop between the power source and the application. Now, some customers will have their own, and there's a lot of customers that don't. So that's why we've introduced this to the market. So it basically completes the closed loop system on these applications. And then further to that, we have seen a lot of interest at 27 megahertz for the semiconductor market and the industrial heating markets. And we're introducing a 1.7 kilowatt device at 27 megahertz. And we also have a 75 watt module with 4 output channels of 19 watts. And that can drive 4 of the 1.7 kilowatt modules. So looking towards Q3, it's going to be pretty busy for us, and we're pretty excited about that.
So given the very broad range of applications, as you look at the opportunities in RF energy, where do you see the best opportunities and how are they driving your product roadmap?
Okay. Yeah. We're newcomers to this market, and I think Q3, as I just said, is going to be a big quarter for us with the 4 new product introductions. And so that focuses on, the first products at 27 megahertz, 2.45. So we will eventually, and the plan is to expand our products to cover all the ISM bands from 13 megahertz right the whole way up to 5.8 gigahertz. And then on top of that, depending on the frequency and the type of application, we're seeing clear demands for different power levels. And our plan is to create a roadmap on these frequencies and power levels that support these multiple applications that we're seeing. So for that reason, our roadmap, we've decided to make it very modular, a modular platform in that sense. So we start with our connectorized solid-state power amplifiers and the ZHL 2425 250 plus. That's an example of one of these building blocks that we call our ZHL products. Sometimes that fits the application. You don't need to do anything else, but then sometimes there's more power required and we get requests for higher power levels. So we've also created a 19-inch rack chassis, and we call that our HPA series. And essentially what we'll do then, if there's higher power levels required, we'll combine a number of the CHL modules into the HPA to get that higher power level. And then even after that, we've seen that we might need to combine even more power. And then what we do is we take the HPAs and we combine them in a rack-mounted system that we call our RMS series, so rack-mounted series. Now, the key to support in the market is essentially cover the frequencies and create the modularity to cover the power levels. And that's what we're actually doing on our roadmap. The combining of high power levels is not trivial. So there's a lot of design effort to get this right, and we're putting a lot of energy in there at the moment. And then the last thing that we're seeing is customization. So we'll add some custom specific tweaks to our products. We've left room for that, and we know that that's part of some of the requirements for the market. So yeah, essentially a lot of stuff's happening, and it's all very interesting. And I think with Q3 just around the corner, we're looking forward to seeing more activity in the market.
Well, Mark, thank you for joining us and for giving us an update on the RF energy market. It sounds like the market is really primed for MiniCircuits to provide a lot of solutions, and I'm not sure you and your team are going to get much sleep during the coming months.
Thank you, guys, and it was good talking to you.
And thanks, everyone, for watching Frequency Matters. Be sure to follow videos.microwavejournal.com for more interesting interviews.